Hey guys, my name is Shashank Kalanathi, and today we're going to be going through PyCaret, which is a library that allows you to quickly create and deploy machine learning models with almost no code at all. It's really simple, but it's a very powerful library. Um, and I should warn you that I'm not a data scientist or like an expert on machine learning by any means. Modeling and statistics do interest me, and I'm in the process of learning how these things work. And this is one of the libraries that I've decided to pick up because of how easy it makes it to deploy multiple models very quickly. You can run through everything from just your basic sklearn models all the way to different boosting algorithms, anywhere from light GBM to XGBoost to cat boost. So PyCaret combines a bunch of popular machine learning libraries and machine learning adjacent libraries into one package that can be easily used. It's quite large and robust and very extensible, so I highly recommend using it. And we're going to be going through a slightly modified version of a notebook created by Farad Gonen because I don't see the need to reinvent the wheel. He has an excellent workbook that I just had to modify a little bit of code and update a little bit of code to follow what PyCaret does today. So we're going to be using Google Colab for this because it was my computer, for some reason, it's very difficult to configure PyCaret to work on it. I have a problem with like light GBM or something. So we're just going to use Google Colab. So going to the computer screen, we will first go ahead and go to colab.research.google.com. I think you have to have a Google account, but it shouldn't be too hard to get one of those set up. And I created a new workbook and called it Farad Gonen example. And then the first command I ran was pip install PyCaret. And the exclamation mark basically is telling the Jupyter Notebook to run the command in the terminal. And so it's going to pip install PyCaret. And I think that's all we should really need. One more thing you'll want to do is you'll want to take the data, which I'm going to be attaching at the bottom of this, in the description of this video, and you'll want to go ahead and download that data and upload it using this button over here. So you click on that, and then you just upload whatever data you need to. There will be three files: a gender submission file, a test file, and a train file. For those of you that have done this before, you might be familiar with these are the three files that are part of the Titanic dataset. Very famous. And I think this is just a great data set to use as an introduction to PyCaret. I would really like to come out next week or the week after with another video where we go through a more bespoke data set, something that I've collected myself and that and like try and solve a real problem with this. But today we're just learning how PyCaret works. We're also going to be specifically focusing on classification, not regression today. I will probably put out a video next week where we look at a classification problem. All right, so now that we have our we have PyCaret installed, let us go ahead and get our data into a couple of data frames. So let's see, I haven't used Google Colab in a while, so let's see what happens over here. So we're going to import PyCaret, import pandas as, come on, SPD, import numpy as np, import OS. So let's go ahead and do that. Okay, so I'm going to do os.get cwd, current working directory. And the reason I want to do that is because on these cloud environments, so all of the stuff that we're doing in Google Colab is running on a cloud environment, meaning that it's running on some computer somewhere else, basically, owned by Google. The way they configure their file systems can be a little bit weird. Okay, cool. So it looks like we're inside a directory called content. I'm guessing that's what this directory is. Okay, so what I can do to see to check and see if this is the directory that they're talking about is I can type in list dir. Awesome, and then we see all the files we need are right over here. So what I've done right now is basically I've confirmed the directory that I'm in, and I've confirmed that what I'm looking at over here, I can access these files very easily. So now I can go ahead and just import the files that we need. So actually, what I used to do whenever I wanted to like go to a specific directory is I used to do pwd, meaning present working directory, equals os.get current working directory. OS referring to, of course, this library right over here. And And that would, of course, output the, it would save the directory to this variable that we created called pwd. But a viewer actually gave me a great suggestion where he said what you could actually do if you want to like create a file path is you could say, so you have your pwd, and then we know our file is called test.csv. So we can create a string with that. And then what we do is we use the function os.path.join pwd and then test CSV. And the reason we do this is that way it creates a string that is OS agnostic, basically meaning that Windows treats its file system differently than Unix operating systems, where you need a double backslash in between every directory that you go through. So and if I'm running this code on a Windows machine versus a Linux machine or a Mac machine, I have to change it every single time. But doing it like this makes it OS agnostic, so I can just throw this code to someone on a Windows machine or even to a Windows machine that I have. And as long as they have the files in the directory that this code is running in, it should work just fine. So what I'm going to do here is we're going to define the present working directory as that, and then we're going to call file, or we're going to say test file path equals this copy, paste, os.path.join present working directory test.csv. And then I need to do that for a couple of other things. So we need to do that for our training data and our gender submission data. And for those of you that don't know what I'm talking about when I mean training and testing, don't worry, I'm about to go over that in a second. So let's see, we call this just train.csv, and we'll call this gender submission.csv. Okay, cool. I think that should get us what we need. Now I should be able to just say train underscore import. That's what I like to call. Whenever I import a file, I always use the import suffix. PD, so PD referring to pandas, dot read underscore CSV test file path. Oh, then we'll call this test import. And let's see, we will have our train import and our gender import. All right, and then let's go take a look at our data. So everything seemed to import as we wanted it to. Oh, and by the way, whenever you see me run a code cell, I'm just using Shift Enter or Shift Return on the Mac. That's how I run code cell. So it looks like our data comes in, looks good. So let me go over the actual problem and what we're doing over here for those of you that may not be familiar. Hopefully I have my data science hub over here. So, and this would also be a great opportunity for me to plug my data science hub. So I'm on a quest to become a data scientist myself, or at least take a more quantitative approach towards my data work. A lot of the work I do is a bit more BI focused right now, and I'm really looking to transition to something more quantitatively focused. And in that quest, I've created a data science hub, which is where I aggregate all of my knowledge and everything I'm learning and all the data sets and resources that I come across into one easy to use hub. And I actually make this public to you guys, and there is a link in the description below that you can use to get to this hub, and just about everything I do will be available over here. So, we have the Data Science Hub. One quick note, any links to Amazon are my affiliate links, and I do make a small commission on it. It doesn't change the price of all of the product you're buying. I just make a small commission on it, which I hope if you're interested in any of the stuff that I'm presenting that you appreciate the authors and buy the products from them. So as you can see down here, I have a section where I just go like, what is a data scientist? And there's this great podcast called Build a Career in Data Science, and the two data scientists in that podcast talk about like the three basic types of data scientists. You have like your data, or the three types of people that work in data science: your data analysts, decision scientists, and machine learning engineers. Explanations where I just go over like stuff that I've learned and how I explain it. So PCA was the first one I did, and we're going to be looking at basic structure machine learning / deep learning. One more thing I wanted to show you guys, a lot of questions I get from people are, how do you find the data that you use? and not just have it be Kaggle. And so I post those data sets over here, and I'll try and organize them as much as I can. So going to basic structure of machine learning problems, what we're going to do over here is we're going to go over a very high-level structure of how a machine learning problem works. So you have three different paradigms of problems, basically, and then you have multiple types of problems. So your different paradigms are supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is basically where you have a set of data and you have the predictions already ready. So for example, you want to predict revenue, and you're using your past data. Okay, well, I know what my revenue was in the past, and I have a bunch of factors, a bunch of features, which are individual columns in a data set, that I can use to predict revenue. And I'm going to throw a machine learning algorithm at it, and it will try and predict revenue. But it already, it knows how to, match these features to the expected result. That is a supervised learning problem. Within a supervised learning problem, you have regression and classification, where regression is you're predicting a value. So in the instance where you're trying to predict revenue, that's a regression problem. If you're trying to predict what car people will buy, that would be a classification problem. Next, you have unsupervised learning, and unsupervised learning is where you throw a bunch of data at a machine learning algorithm and tell it to find insights for you. I am simplifying over here. It's a lot more complicated than just throwing data at an ML algorithm. But you have clustering is one of your most basic forms, where basically you throw a bunch of data at the algorithm and say, group this data into groups using the different features I provide you. Remember, features is just a word for columns. And tell me what the different groups are, where the different groups are. So I can see, customers that like products from Sony also happen to buy Toyota cars. And they, like iPhones, something like that, find these associations that I wouldn't normally find. And then you have reinforcement learning, where basically you give a machine learning algorithm a punishment or a reward based on different actions that it can take. This is really common with neural networks. And this is something that's a little bit more advanced, and I don't have any exposure to it personally. The only machine learning algorithms I've used are supervised and unsupervised. So I don't want to speak too much on that because I don't know too much about it. We're going to be working on a classification problem using the Titanic dataset, which is a very common dataset that people use to get. It's kind of the hello world of data science. Basically, it's a bunch of data on passengers in the Titanic and whether they survived or died. And you need to predict, given all this data, did they survive or die? So we're going to be using classification to predict whether given a bunch of information about a passenger, whether they are a survivor or a fatality, I guess you would call it. So that's what we're going to be doing over here. Just wanted to go over that and level set with everyone. And I just want to make sure that everyone's aware that I try and go as explain everything that I do just to make sure that no one gets left behind. But that's what the skip button is for on YouTube if it's too basic for you. So we have our data. Now let's go ahead and we've installed PyCaret. Let's go ahead and set up our machine learning algorithm. So there's a couple of things we need to do in order to set everything up. I'm going to kind of be speeding through it. So what we're going to do is we're going to call the CLF1, and we're going to say equals setup. And then there's a lot of parameters that we have to fill out over here. So one is, what is the data set we're going to be looking at? So data set equals, and I'll fill this out in a minute. Next is the target. And the target is basically in a given data set that we're looking at, what are we trying to predict? So you'll see in our training data, you'll have a passenger ID. Survived is what we want to predict. One, actually, I don't know which one means survived and died. I think 1 means survived and 0 means died. Only because I see a couple of women over here, and my understanding is that, misses. And my understanding is that women tended to live more than the men did on the Titanic, and I see a lot of 1s for the women. So 1 means survived and 0 means they died. So we're trying to predict survived using all these other classes we have over here, all these other features we have over here. What class was the passenger? What was their name? That probably won't do anything. Sex, age, number of siblings they had, parts, I'm not too sure what that is. Passenger, I'm not too sure what that is. Ticket number, fare, cabin, embarked. It's a very small data set. It's not very complicated. So target is what we will actually be wanting to predict. Numeric underscore imputation. So imputation basically means if you're missing a value, what do we replace that value with? You can either drop the value or you can impute it with a mean, a median, a mode. And the reason you want to do this is because machine learning algorithms usually don't do well with missing data. So for example, if data is just not there, so we didn't know the fare for this person, for example, we would need to replace that value with something. Sometimes you want to drop it. Sometimes you want to impute it. There's there's an art to exactly what you want to do with that data. And that's really beyond the scope of this video, but I will definitely put out a video in the future where we talk about that. Categorical features. So categorical features are things that are not numerical. So things like, in this case, the name, the age, the sex, the ticket number, probably the cabin would be categorical. And these have to be treated very differently from numerical variables. Where numerical variables, you can run a bunch of statistical tests on them. Categorical variables usually have to be transformed. They have to be changed into some numeric form before you can run a test on them. And that's where you have things like one-hot encoding and just standard encoding and stuff like that. Again, not something we're going to worry too much about here. Ignore features. Again, features just means columns, and ignore features is what features do we want to ignore. And then silent. So what happens is PyCaret will want to confirm. So PyCaret, when you give it a data set, it'll try and figure out, oh, what is this data set? Or sorry, what data type is every column? And that's very important. And silent basically means don't ask me after, to confirm, because what happens is it'll try and, predict the data sets and then ask you, confirm this. For the sake of time, we're just saying silent equals true, which means it'll just, blaze through everything. So the data set we're looking at is train import. The target is going to be the name of the column we're targeting, which in this case will be survived. The numeric imputation, I guess we'll just use mean. That's just a standard way of doing it. It's not always the best way to do it. For example, if you have very skewed data and data with a lot of outliers, means are very heavily affected by that. So you don't want to just be switching out all your missing values with the mean, because you could be giving it crap data. And probably one of the biggest rules of data science is crap in, crap out. If you have bad data going in, everything else is going to be messed up. And it's why data preprocessing is so important. And that's what this setup module does. It helps you with the data preprocessing. So the categorical variables we're going to be including are sex and embarked. And then features we're going to be ignoring: name, ticket, and cabin. Name will probably not have a great effect on what happens. Ticket, again, if you look at the ticket column up there, you'll see it's a bunch of gibberish basically. And then cabin, so much of the data is missing. For the sake of speed, we don't really want to worry about that. And then silent equals true, meaning that we don't want it to confirm everything with us. So shift enter. CLF1 is not defined. Oh, sorry, this is a minus. That should be an equal sign. There we go. Setup is not defined. Okay, so usually I just have to import PyCaret. Maybe I have to from PyCaret import setup. Interesting. Let us see what the problem is here. Okay, my bad. So actually, this import was wrong. What I need to actually do is from PyCaret dot classification import star. Basically, import all of the modules inside PyCaret dot classification. And again, we're doing a classification problem, so that's exactly why we're importing that. Okay, let's go down here and let's run this again. Awesome. So you'll see what it did over here was that it lists all of the different setup, parameters and what it did. A lot of this is very much beyond the scope of this video, but I would really love to get in depth in this. And actually, I'm thinking about buying the Hands-on Machine Learning book by Aurélien Guéron, which it's a standard book that everyone reads apparently, and going over it chapter by chapter, week by week with you guys. So let me know if you guys are interested in that. We can go ahead and do that. All right, so went ahead and did that. Works just well. So now let us run the next line of code. So just got to make sure I have my... Okay, cool. So I think all I have to do now is I just have to type in compare models and just run that. So what happened, and this is where PyCaret is just beautiful, right? Like you did that setup thing, and that, you know, that took the better part of like 20 seconds. And now I just run compare models, and it'll take this PyCaret object over here, CLF1, and it'll automatically start running a bunch of models on it and giving me the results of those models. So you'll see it ran a gradient boosting classifier, K nearest neighbors, quadratic discriminant analysis, ridge classifiers, eta boost, random forest, and then I think it even orders it in the order of best accuracy. Accuracy being the standard metric by which you measure the quality of a classification machine learning algorithm. So when you run a machine learning algorithm, you obviously have to check, you know, is this accurate? Does this do what I need it to do? And accuracy is your most standard-based metric. There are a lot of problems with using accuracy too. One of the big problems is that if you have a lot of like one classification, like you have 99% of, you do cancer screening, right? 99% of people won't have cancer. And so if the model were to predict every single time that no one has cancer, the accuracy would be 99%. But that's still a failure of a model because the whole purpose is it's supposed to predict who has cancer. So accuracy is definitely a good metric, but it needs to be balanced out with AUC, recall, precision, F1, your kappa metric, your MCC. I think that's like Matthew correlation coefficient or something like that. And I've given a good write-up over here, which I'll share with you guys also. It's inside the Data Science Hub. If you go down to Machine Learning under PyCaret, and then go to PyCaret, an Introduction by Farhat Gonen, you'll see this is the workbook where I explain exactly what all of this stuff is. Where is it? Yeah, all of the different metrics. So you'll see how easy it is. You know, like obviously, you know, I'm explaining it, so it took a little while, but like in what is effectively 2 lines of code, we've already run like 10 different models. This would take a lot of like doing with if you had to do these models individually. And now we know our best model is probably going to be a gradient boosting algorithm or gradient boosting classifier. Yeah, it looks like just with almost all the metrics, it's the highest. So that's probably what we want to be using. The next thing we want to use is I want to show you guys something called create model, where let's see, create model. Create model is the same thing as compare models, except it'll let you create a very specific model. So we're going to use light GBM. And so it'll only run a light GBM classifier. Light GBM being a boosting model that was developed by Microsoft. Great thing about boosting models is that they're very light on your computer compared to like neural networks, for example. And they actually they have like great results as far as like what they are able to, the accuracy of their predictions. The only problem is explainability can be a little bit difficult with them. So you'll see it ran light GBM, it ran it 10 different times, and we got our different metrics over here. And then what we can do is we can tune our model. So we can say, let's see. So what we actually want to do is we want to assign this to a variable. So light GBM, let's just say that. And then we'll say tuned LGBM equals, what is it? Tune underscore model LGBM. And what all that means is we're going to be tuning something called the hyperparameters of the model. Hyperparameters are they are the variables that are not affected by training your data. And what we do with a machine learning algorithm is we always, we give it a bunch of data and train it on that data, and then we test it out on our testing data. So when you're training, you basically give it the data and say, hey, here's a bunch of data, go learn something. That's effectively what it is. That's why it's called machine learning. And then you test it out on test data, which is data it's never seen before. And you say, okay, now that you've learned all of that on the training data set, like run this on the testing data set, and did you learn anything? Like, tell me what you learned. And we see the accuracy versus the testing data set. And then you tune these things called hyperparameters, which are just a bunch of parameters that can be tuned that are not affected when training the model. So if this all seems very complex, we'll have videos in the future where we go over this. I actually took a course on Udemy that taught me a lot of this stuff. It's by Super Data Science, I think. That's the one I used. And then we can also plot our data over here. So let's see, we go plot model. So you want to like plot your you'll want to plot your models and like see how they perform. So estimator equals tuned underscore LGBM. And then the plot I want to look at is the learning plot. Syntax error. What am I? Plot underscore model. Estimator equals tune LGBM. Plot equals learning. There we go. And you'll see we'll get a nice plot that'll show us how our algorithm is learning. Again, we'll go over this in a different video. But I do have I explain all this stuff in the workbook and the notebook that is attached at the bottom of this video. We can also look at our AUC curve. So plot underscore model estimator is that tuned LGBM model that we have. And plot equals AUC. Nice. And then we can even do like a confusion matrix. It's the wrong estimator. And what a confusion matrix tells us is it tells us how many, basically, it gives us a breakdown of how accurate was this. Basically, like, did it predict everything accurately? So you'll see there's a 0 here and a 0 here. So what did it predict and what did it get? These are accurate, and then you'll see a 1 over here and a 1 over here. These are accurate. Basically, like when it was actually a 1, that's the true class on the y-axis over here. Versus what the predicted class was. So these over here are really what you're looking for. These are incorrect. These are your, let's see, true class is that. So this would be your false negative and your false positive. And then these are what you're looking over here. Your true negative and your true positive. So that's what you'll want to look at. So a confusion matrix is a great way to see, okay, this is actually how well it predicted what I was looking for. And then we can even do something called feature importance. And this I thought was super cool, where it'll tell us what feature was, so plot model estimator equals tuned LGBM. So you'll notice that this code's all the same. You know, I'm just using plot model, I'm using the exact same estimator, and I'm just changing what the plot is. This is how easy PyCaret makes it. We can see fair is probably the most important variable, basically meaning that probably the more money a passenger paid, the more likely they were to survive, followed by their age, followed by their sex, if they were female specifically. So these are all important things to determine the survivability of passengers. And then we can also evaluate the model. So evaluate model, let's see, let's go tuned LGBM. And we get a bunch of metrics that tell us, okay, like here's how it actually performs. So you'll see these are the different charts that you might want to see. And I would, again, if you want to learn machine learning, I'm actually thinking that this is the great way to do it, where you just mess around with this library. And there are all these terms I've never heard of that I'm going to research one by one and expound on them in notebooks that I'll share with you guys. So I think this would be a great opportunity for all of us to learn how machine learning works. And then the last thing I'm going to show you is something called interpret model. Tuned LGBM. No module named SHAP. Okay, so this is a problem that you can run into with PyCaret, where there's a module called SHAP, which gives you these things called Shapley plots. And it looks like that didn't install. So it would take too long to figure out exactly what the issue is over here. But when it works correctly, it looks kind of like this. This is the plot you're looking for. And then you can even use it to predict your data. So let's go ahead and predict. And you'll see, basically, all we've done is we've written like 10 lines of code. Test is not defined. Test underscore import is probably what we're looking for. And it gave us our predictions over here too. Um, and you'll see, we wrote down maybe 10 lines of code, and we've deployed, and we in those 10 lines of code, we were able to pre-process our libraries. We were able to test out 10 different models, 10 or more different models, and they keep adding new models really. And then even tune the models very easily. So what PyCaret does is it makes it very easy to go from knowing nothing to knowing something about your data. And from there, you can kind of like more accurately be like, okay, we want to go in this direction. We want to use this boosting model because it is the most accurate. Or we want to just use a regular straight linear regression because we need something that's very explainable. And that's more important than accuracy for us. For example, people that work in banking, that's apparently something that's very important to them because they need to know if loan applications were rejected or and why they were rejected. Explainability is very important for that because of all the regulations surrounding it. So PyCaret is a tremendous library to get started with this kind of stuff, and I think it's a great way to see all the different terms that you'll have to learn to be a solid machine learning practitioner. So that's all I have for you guys today. Thank you so much for joining me. If you have any questions or concerns, please leave them in the comment section below. I always try and answer as many of those as possible. And I hope you guys have a great day. Thank you.